So who's this guy? That's my name, apparently. My name is Maffia, and I do come from Italy, not from Sicily. I'm a Dynamic certified developer, and I've been working with Dynamic since, I guess, 2010, roughly, when the meetup in London started. But I do also pretty much do all sorts of other stuff with the web. I work for a big international company, so we do web stuff, web application, and other sorts of things. There's a picture of me with a really good Photoshop. Right, SQLite. So what actually it is SQLite? SQLite is probably, I don't know how many of you guys who work with SQL in general, with MySQL, Microsoft SQL, Microsoft Access and Excel. I'm not that okay. If you are, put the hands up, you can go out. SQLite. So SQLite is a small library written in C. It can be average of like 300K, and what it does is basically it creates a self-contained, serverless, zero configuration, transactional database engine. So what are all those buzzwords actually mean? Self-contained. It basically means they require very minimal support in terms of external library. There is no actually connection like with operating system or sort of these things, and that basically makes it really well suited for mobile application, right? Because you don't need like a big powerful desktop environment needed, right? Serverless. As you may be aware, right, when you work with other classic database engine, you are basically work with a separate, usually server process, and you interact with the server process, communicate with some sort of like, I don't know, TCP/IP. So you usually try to connect to the server from the client, sending some query, then you wait to the server to give you a response back through the TCP/IP and all sorts of things, right? With SQLite process, actually, the ones access the database actually read and write directly in the file system of your device. So there is no this concept of a server process. There are a lot of advantages in this case. You can think about a bad scenario, or a bad, let's say a bad point, because basically you don't have an external process. So there is a bit of like, you know, you have somehow a better protection if you have a server process running the SQL and the client that doing just the query. But that's one of the things in the SQLite. One of the benefits for sure is that there is basically no setup. There is zero configuration. You don't have to do anything to use SQLite. Doesn't need to be installed. There is no concept of like setting up the SQLite to actually start it. There is no concept actually, as I mentioned before, of you know, a server, actually a server process that start or end or restart. You don't need a DBA, right? You don't need an administrator that give you access to the database or give you like random permission to read and write in the database. There is no configuration file. Basically, you don't even know if SQLite is running or not. It just runs. It's there, and you can just use it. There is no setup at all. One of the nice things is transactional. I'm going to explain a little bit better later on what it actually means. But basically, all the change within a single transaction in SQLite either occur completely or it doesn't happen at all. So basically, SQLite can handle for you if the client crash or if the operating system crash, on these sorts of things. SQLites are a really cool feature of rolling back whatever was the previous status before even it. So if you are in the middle of an operation and your mobile application crash, SQLites automatically roll back from the previous operation that you were running, and that's one really cool feature. Duck typing. Anyone familiar with duck typing? Right? The duck typing is an interesting thing in SQLite. Some say it's a feature, some say it's a bug. If you're familiar with duck typing, what it is, it's basically, if you look like a duck, if it acts like a duck, if it works like a duck, it must be a duck. And what SQLite, in SQLite, what all these words means, duck typing comes from like languages as Ruby or Python, that are all duck typing. There is no actually constraint in the data type. Again, if you're familiar with the other SQL database, databases usually tend to define the data type. Okay, I want this column to be an integer, I want this column to be a string, and so on and so on and so on. SQLite, it doesn't really care. You can put whatever you want. And I mean, in one sense, it's actually a real feature, because if you want, you don't even need to specify what's the data type for that particular column. So, and it has actually even like a really cool feature that to actually work backwards with the other SQL engine, if you actually define something that is a string and you're trying to put an integer, it will let you do it. In the other way, if you actually define a column that is an integer and you actually try to save a string, but that string actually, it looks like an integer, it will do the conversion for you. So it's one of these, it may be a weird thing. Some say, again, if you search online, some say that it's a feature, some say that it's a bug. It's called duck typing, and I think it's quite cool. What else? Let me see. Limits. Limits in SQLite in this context is actually meaning in terms of like the quantity, numbers, not generic limit of when to use a SQLite or when not to use it. Originally, when all the guys put them together in a room and they started to say, right, let's create this library for creating a database engine, SQLite was originally designed with one policy that basically was having no arbitrary limits. Actually, the policy was that it would fit in the memory and you could count with a 32-bit integer, then it should work. The reality, though, it's like, it's not always so great. So, because the upper bounds were not well defined, there were all sorts of bugs happening when actually SQLite was pushed to the limits. So there were weird things happen, like even like possibly security exploit were could happen. So they rolled back and said, okay, we have to define some sort of limits, because of course we cannot count how many machines the database engine is going to run, so we don't know everything, right? But those limits are quite high, and if you current these limits, maybe SQLite is not the real, the database they should use it if you really need to go more than those limits. There is, if you go on the website, there is all sorts of like list of numbers and limits. I'm just putting a couple of them here. You have something like 1 billion is the maximum length of a string of a block. If you have to store something bigger than that, probably, I don't know what you're doing, but probably SQLite is not for you. 2000 is the maximum number of columns that you can have. And 64 is the maximum number of join between tables that you can have. Honestly, if you have to go that big, maybe a relation database makes much more sense. Right? If you go on the link, there are a lot of more like limits in general and other sorts of things. So that's roughly SQLite. Are you guys still awake? I know there is siesta time for how many Spanish people we have. I know there is one Spanish people there, one Spanish people there. Yeah. Just don't fall asleep, right? I know it's siesta time, but so how to use SQLite with a Titanium database? There are basically two ways that you can use SQLite with Titanium, and one is actually to create a database, and one is actually to install a database, an external database that you may already have it, right? Create a database, basically, you can create an empty database, and you define all the structure and the contents through SQL statement inside your Titanium application. The install procedure is a bit similar. Basically, you just import a database from your resource folder, and that file actually gets moved to whatever is the folder inside your iPhone, SQLite, or Android local for your particular application. I'm going to show you a bit of code. Let's see if you can see it. Can you guys see it? Yeah? Roughly? I mean, just quickly. This is actually to show you how to create a database, one of the two options. You call basically the ti.database.open, and you pass whatever you want to be the database name. What that guy does, will create a database for you, and will pass you back a handler, right? Then you can use this handler for doing query and all sorts of things. In case the database already exists, because in some piece of your code you already use the open, what it does, it doesn't create a database again and blank and everything. It just returns the database that was already in the system. So it's a way for open or reading a database. And then you basically you do everything there is not actually an abstraction library in Titanium, so you actually use a SQL statement. And the SQLite pretty much supports all the common SQL, generic SQL database statement, right? So you run everything with a db.execute, and then you wrap inside your query. So in this case, I'm creating a table. If it doesn't exist, a table called speakers, I'm passing an integer as a primary key, a name, a bio, there's a text, and the URL, and so on. And db.close. I'm going to mention it later on, but always close the db or the record set. And that's one of the tips I'm going to mention later on, and I'll tell you why. One little thing, if you are doing iOS and you are developing for iOS 5.0.1 plus, the database that you're using in SQLite will be actually saved as your user data in the cloud. Let's put the microphone off, that's fine. If you guys can hear me. Yeah? No, right. Yeah, basically the database that you get saved in the iCloud, in your user data that goes in the iCloud. And you have to be careful because Apple can actually reject your application if you start doing crazy thing with SQLite and saving a lot of things. They starting to see that all this data that gets saved to the iCloud, so they can reject your application. And you can use actually, once you define it, you open your database, you can use as a set remote backup, default false, and they actually avoid the database to be saved on the iCloud. Install, on the other end, is basically the other option. It's really simple, and it's basically ti.database.install, and you pass basically whether it's the resource folder in your application and the database name. And again, it return you a handle. And as I mentioned before, what it does, it just copies this flat file that you have installed it somewhere, or you create your database somewhere else with any other external UI. You copy it through the simulator, to the phone application, and so on. Another neat thing about the install is if this copy operation happened already, it will fail silently. So if you already installed this database in your resource, it will actually act as the open. You will just reopen the database instead of a copy. But you won't notice anything, you won't get an exception, you won't get anything, just silently failing and reopen the database for you. All clear so far? Yeah? So let's use it, right? As I mentioned before, there is no actually extension in Titanium to running query in SQLite, but use any SQL statement to actually manipulate data, writing, reading. You need a simple writing for the database. Again, the db.execute is your method, and in this case, I'm just insert into speakers table, name, bio, URL, and the values. Titanium has this kind of interesting technique of using unnamed parameterized query. So basically, you can pass your query with a bunch of question mark. Then you close the query and you pass the parameter value that you want to assign to that insert, right? The db execute, you will return as well a record set, but for things like insert and delete, you don't really use it. You will use it later on for the read. And again, you have a bunch of other, a lot of actually methods that you can run on the db namespace, like last insert row. It will give you actually what's the ID last insert of your database and so on. The read is not much more complex. Again, it's the db execute, you run a simple query with select in this case. I'm selecting name, bio from the table speakers, and then you basically run a loop. In this case, I'm running a loop with a while. Using that method is valid row, so that loop will actually end as soon there is no records anymore in your table. You have to make sure, of course, you're calling the speaker record sec.next at the end of your loop. And what I'm doing in this case is just reading a field by name. So you actually pass whatever was the name of the column of your SQLite, in this case name and bio, and I'm assigning it to variable. You can check the result. Right now I'm just printing out the debug with the ti.info. And again, I'm going to the next record set, reading the value, saving the variable. In this case, the same variable, we just do an example, and then again closing the record set. Same thing also for the DB, you have to close the record set as soon as you finish your operation. And that goes to actually to the tips and tricks. So yeah, what I was mentioning, close the DB connection, close the record set, always, never forget. You also get an exception if you don't do that. Transaction is really cool thing that I will tell you. Try to avoid, when you actually run the install, instead of creating a new database, try to avoid to ship your application with a big DB already, and I'll tell you why. And then one cool thing is actually a tips. Use a version number for your database. I'm telling you what. db.close. Right. Basically, it's really simple. Like in mobile app, you are dealing with a single user memory constrained environment. So if you don't actually close DB, your memory that the application is getting bigger, bigger, and bigger. And sooner or later, it will probably fail, and you will run out of memory. You will actually throw your database object not close exception if you don't do it and you're trying to read the database without the db.close. So again, it is the same as to do for the record set. So if you're doing an insert or update operation, always close it. The transaction that I was mentioning to you, it's a really cool thing. Not many people actually know about. But if you go actually in the FAQ of SQLite number 19, the transaction can be used to speed up the insert. And that's one really net thing. Basically, how SQLite works, for each insert, run in its own transaction. So there is actually a writing on the file system, right, for each insert. So if you think instead, like what you can do, if you know that you are doing a loop for whatever reason and you're trying to insert, I don't know, 20 different, you're trying to do like 20 insert in this particular loop. If you can wrap the whole loop in a begin and commit, the whole operation runs one instead of running like 10 times. So what it happened, basically, SQLite group all the operation and just run one query, one writing in the database, and that's much, much, much faster. So if you think about like, I don't know, even already like 50, 60, you use the whole thing quite dramatically. Basically, yeah, as you said, as written here, you create a single massive operation against the database rather than 10, 20 little ones. And the cool thing, as I was mentioning before, because SQLite has this concept of rollback, if those operations basically fail for whatever reason, because you're running out of, I don't know, the network, you're doing something with the network and the network goes out, or the application crash, the whole operation actually failed. But as soon as the application run again, it will start actually from the previous operation. So the whole operation gets tried to be submitted again. So it goes back kind of like the previous operation in the stack and then tried again, the whole thing. The other tips, try to avoid to ship your application with a big database. What it means that your application is going to be huge. It means that you upload it to the Apple Store market or to the Google market store will be huge, and your user will be affected because they try to download your application, they have to download like 100 megabytes because you ship 90 megabytes of database, right? So you can do a lot of like cool things. What you can do, maybe just ship like kind of like skeleton of the DB, so just the structure and maybe just the minimum amount of data your application needs to run, right? So the user that already application is started has the minimum amount of data to actually play with the application. Then you can do all sorts of things. You can ask the user, right, welcome to the app, blah, 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 why you don't get the updated version of the data? And then you're doing all these sort of things through the network, right? So you can upload, update the actual internal database with external data that run in your classic DB that you have on the server outside or whatever REST API that you can do. And again, that's to avoid actually that you ship like a big application. And that's kind of like the next tip, to actually give a version. Include a version table in your database. It makes sense if you think about what I was saying just now, basically in a way to know which data the user actually is running on his device. Because there's a lot of different options that you don't really know what's happening, right? If the user is really running the old version, or which version of the data is running in his mobile, or maybe the user updated the application, but you don't know which data is still running maybe he was trying to update the data, and the whole update failed for the network problem. So you don't really know at that stage the user which kind of like data has on his own device. So you can run all sorts of crazy things. And it's really super simple. Of course, you have to manage the version number. It's something that you have to write. But it's just like a matter of adding like a simple table with a version, and then you can say, right, as soon as the user download the application is version 1.0. If you update with the new version, it's 1.1, and then you can do your sort of query and say, right, he has the new data. Now I can keep working on, or the update failed for whatever reason. It's still running with 1.0, so let's try again until the version goes to 1.1 and so on. Next, this is one of the first app. It's not a sponsorship. I mean, if you go and download, you give you some money, but it's fine. This is one of the few first app that I did using at the time. And I guess it's like 2 years old or something like that. It's really a simple concept. What it does, it communicates with the Foursquare API and just pull out all the data from Foursquare without asking the user to log in, right? So the first thing, the first problem that I was running through was, of course, like, if you ever guys work with any API or any software API, you probably run out in all these things. They are free, but they are not unlimited, so you cannot actually call them like every 3 milliseconds and getting like 300 record set for everything. So all the different providers, Foursquare, Google Maps, Twitter, they all have limits, and you have to somehow deal with it, right? So when I was building the application, I was trying to think what could be a solution for my simple app to actually avoid running the Foursquare limit, and then Foursquare was just giving me an error and the user was not getting any data and so on. So I was starting thinking, I was like, well, you know what, I don't really care, whatever happened. And I was like, not that great as a solution. Once I reach the limit, the user will pay the consequences, the user will shut down the application, will send me a message of an email, your application sucks, and so on. And I will deal with the consequences. I was thinking, okay, I could probably limit the API call in some sort of like time frame, or set the interval, or do some crazy things. And it was not that great solution. And then I was like, right, why I don't save the results that I get from the API in the files, right? You can just save it as a file. But then I was like, okay, how many files I'm going to have it, and how I'm going to manage, like, what I'm going to save. I'm going to save the API code, I'm going to save the results, how many files for API, so I was starting getting really messy. So, of course, like, what could have been a solution? I guess you guys guess it, being here. I think, yeah, almost there. Yeah, right, SQLite was the solution. A bit of code. So I was in my room, like, as probably all of you, not doing that much at night, at midnight, and try to hack in some code. Maybe you should go out and find some girls.
That's good.
So I was hacking around and tried to find something, and I built some sort of module to actually use SQLite for caching. Until one day, that's the beauty of the internet, you spend hours and hours building these things, and then you found out that someone else on the other side of the world actually wrote the same things. And I was like, right, that just wasted my time. I didn't get any girl. So this guy, I think he still works for you. He's one of the engineers. He basically wrote this module. I was also in chat with this guy. Right, I think you did a bit better than me, so I'm using your stuff. It's just a simple function. I'm going to show you the bit of code. This is just a self-executing function. There is some minimal configuration if you want to disable the cache or not. You set an expiration interval in seconds, and then you have some public function like get, put, delete. Just to give you an idea, what I'm doing here is just extending the ti.app namespace with my unique namespace, in this case initCache. And it's really simple, the whole concept. I'm going to show you a bit of code later. Basically, every time that I'm making an API call, I'm calling the put method, right? So I'm saving whatever results I get from Foursquare in this case. I save the whole JSONDB in a SQLite. That's it, no big deal. And if the user is trying to do a pull-out refresh, or is moving 5 meters, something like that, then it's up to me to decide what I want to do, right? In this case, for example, what I do is like, right, if you you are not moving, you are in the same location. So you can doing something nice, or like, you know, you can set a radius around the user, so like if he's going to move 10 meters, then I'm going to make another API call. But if it's in the same radius, I'm just loading the same data from the cache. So the user doesn't really notice anything crazy. And in this case, it makes sense, right? There is no new data. If you're standing here, there is not much that Foursquare is going to tell me more if I keep refreshing, right? So to show you a bit of the code, the initCache is simple. You just create a database called initCache in this case, create a table if it doesn't exist, and if you see what my table has basically just a value, in this case I'm just saving the whole JSON object there. As an inspiration column, they will be actually the timestamp that I'm running, and the unique key. Closing the db, here I'm just debugging some stuff, and then I'm setting an interval. Basically I'm calling that function the expireCache every tot seconds defined on my application, right? The expireCache, what it does, reopen the database, checking the timestamp, it make just a simple query like select to see how many objects will be deleted, just for information purpose. You could probably avoid this whole operation here. This is just like for debugging purpose, right? And then you actually delete from the cache database any object where the expiration column is minus or equal whatever the timestamp, right? And just debugging, closing the B, and so on. The get the concept is pretty simple. Like you return a null if there is no object, or you actually return the JSON object. So then in your application, you know if you're calling the get and return a null, probably the object is expired already, so you can call the new API from the server instead of from the cache. And again, just like a simple select from the cache, where the key is that unique key that you assign every time that you write in the database. And here is just check, okay, if it's a valid row, give me the result, doing the JSON parse, otherwise just return the null, and as a debugging information here, okay, there is a missed key object in the cache. And the put, as you can imagine, is pretty much a similar concept. Expiration seconds, I'm basically just insert or replace into the cache that particular key value with that particular expiration in terms of timestamp. Delete doesn't change that much. Just delete from the cache where the key is equal to that particular key. And this is just like the whole public method of the function, right? So in this case, I'm returning as a public method just the get, the put, and the delete. This guy just initialize the whole cache, and that's pretty much it. Any questions so far? No? I can show you a quick demo. If the network works, check. You guys running, have you ever played Sublime? Sublime is also. Speed for iOS. You need to have the CLI installed. So it's a small JSON. Yeah, it's a small JSON package that you start in Sublime, and what it does is just call the terminal, and it does the build for you. And it's cool because we have all the debug information here and sorts of things. Let's see if the network works. Try. Let me check something. I don't know which Wi-Fi I'm connected. Just want to show you the debug information that you probably won't see that much here. To show you. Let's see if it works. Right. I think I set the Astoria actually hosted. So these are actually Foursquare tips. You can see here, for example, in this case, I'm just saving some stuff in the cache, right? there is no expiring object, so if I refresh this guy, I don't have it anymore in my cache, so if I do a refresh, it will be actually from the server. So now it's doing make an API call, yeah, it's a bit slow, but there you go, so these are new data. That's pretty much it. In my case, I'm actually deleting the object every 5 seconds or every 10 seconds, but you can change the module and do the things that I was telling you before, like you check if the guy actually moved it like 10 meters, then right, it's fine, make another server call, otherwise keeping the cache version. And that's pretty much the same for all the other stuff. These actually show you all the place around you. The check what I keep seeing yesterday. Alright, that's pretty much the same concept. If I call this guy again, it's going to get calling from the cache. And you can see that it's much faster. I'm not doing any API call to the server. We're good? Cool. Let's close. Sure.
SQLite approach is cool. Have you tried HTTP expire approach? Yes, caching mechanism.
Yeah, using the web, but then I don't know if it works if you open up the whole thing with web view, yeah, with the output.
It doesn't understand
The old expiring cache.
expired policy of
Right. I'm not 100% sure if it works with HTTP client, but you have to be in a web view, or it works. No, it works just with HTTP client. Okay, that's good. Cool. What's next? That was an old joke that I made during the. Liz already laughing because she's on the slide. Not here, actually. And the guy's answer is actually you write a distributed map reducing function in Erlang. And Bob answered, you just tell me to myself, and the guy said, I believe I did go. Welcome to NoSQL. So NoSQL in Titanium. I don't know how many of you guys actually play with NoSQL. So some of you knows what NoSQL it is. It's basically, these are definition from Wikipedia. Broad class of database management system that different from the relational database system. There is basically no fixed table schema, right? In NoSQL, you say if you're from MongoDB, it is what I was saying before, right? It's a key value store. You say whatever you want. The cool thing about SQLite we told about, right? There is one tricky thing. SQLite is great, but this is actually one of the queries that I'm running in the application I will show you. It's starting getting really ugly if you have to write a lot of stuff, right? You ended up having Titanium or something like that. Doesn't matter if you're wrapping in your editor, or if you're along the line, or like it never ends and you start scrolling, it's starting getting ugly. And then a couple of years ago, I found out those awesome guys in Australia, Ireland Gaming, that they built this game in Zombiehood, and one of the guys, Daniel, I was in a chat with him last week, and I'll tell you why. He actually created JSONDB. JSONDB, I'm telling you why he actually did it. So their whole application is basically a game application, and it saves everything that the game does, right? In a SQLite. So it saves the position of each player, and then it's a blind player, so it saves the position of all the other guys, and so on. So they made a huge use of the SQL database. And then they found out it was really slow and difficult to constantly modify and re-index and deploy a new schema when there was an update of the application. So I introduced JSONDB. JSONDB is a kind of like a library they introduced it. It's secure. You actually sign the whole file where the database gets saved, so it's secure. It's kind of like encrypted. Again, it's file-based, so it's easy to maintain and portability. You can just grab the file and send it to another machine. Simple. You can read all the SQL query, and you actually use an object, the way JavaScript was meant to be, right? This is just a quick example. So what you do, you just require the module, and then you work in a kind of like collection way, the same way you work with MongoDB. You create a new collection, in this case complex, and you just save an object. So if you see here, I'm not defining not even like any data table or anything. just say, right, I want to save this object with this value and this parameter, and that's it. Then you commit the whole collection, then you can run also the query like find, anything that has name, speed, you can even do like register with a limit, sorting from that timestamp, and all kind of sorting stuff. You can read more on this website. Just still 5 minutes. Just still 5 minutes. I'm almost done. Again, as I was mentioning before, as all the good things in the web, after 1 year they are deprecated. And they're obsoleted, and whatever you've been working is not working. So the guy actually, I was telling you, I actually posted a tweet and then I was Skyping with him from Daniel. He actually went on and rewrote the whole JSONDB concept in a much more hardcore way. And that's it's called the SQLJS right now. It's a really, really cool library. This is actually what he wrote me. The vision that he had with SQLJS was not just to replace JSONDB, but he does an awesome thing. Basically, whatever query that you write, he pre-compiled in bytecode and running in a separate virtual machine. So it's really, really well optimized. And then he does all sorts of things that were hard before with SQLite. So he normalized the whole expression. It has the indexing of your SQLite, so you can choose even like which data you want to index for future search, right? So it's much faster and those sort of things. And the cool thing is not just for the time SQLJS, you run in anything that runs JavaScript. So you can use it with a Node.js process, you can use a simple iOS or Android application as long as it's run with JavaScript environment. Check it out. GitHub is Dan SQLJS. I'm going to upload anyway the slide. And that's pretty much it.